Hello everyone, welcome back to the session of data structures. In today's session, we'll be going to see how to implement a stack using arrays. Before going to that, we'll be seeing that in how many ways can we implement a stack. After the end of the session, you will be able to know how to implement a stack using arrays. Generally, before going to in detail, we have to know in how many ways we have to implement a stack utility. We can implement a stack either by using arrays and also by using linked list. When we use this arrays, when we know the amount of data, when the amount of data is fixed, then we go for the stack. But when we don't know the amount of data we need to insert, organize, then we go for linked list, where we can insert organize unlimited number of elements or data. First, we'll be seeing that how to implement a stack using arrays. For implementing of stack using arrays, first we need to make use of a variable called as top, where it should be assigned to -1. It should be initialized to -1, where it states that it is an empty stack. And the stack is incremented or decremented based upon the number of elements we pushed onto the stack and popped out from the stack. And also we have to declare the size of a stack prior, so that we can insert only the number of elements depending upon the size of a stack. Let us see the algorithm for inserting an element onto the stack. First, we have to check whether the stack is empty or full. If it is full, we cannot insert the element onto the stack. We have to directly state that the stack is full. If there is some space left to insert element onto the stack, first we have to read the data that what we have to insert. Then after that, we have to increment the top. Initially, it will be -1 when there are no elements on the stack. When the top is incremented, then at that top position, we have to insert the item. See here, we have a detailed explanation of this algorithm. In the first step of the algorithm, we have to check the overflow condition, that whether the stack is full or not. Overflow means inserting an element on which the stack is full. Again, if top value reaches the maximum size of the items cannot be inserted on the stack, that states that the stack overflow condition. Otherwise, we have to increment the top, and then we have to assign the value at that topmost position. See here, here is a source code, and we'll just see the tracking of the source code, that how the insertions and how we can perform this push operation onto the stack. Initially, this is an empty stack. First, we have to take an element, which we have to declare an element. If I want to insert an integer element, I'm declaring with as integer data type. Now, I'm checking whether stack is full or not. If it is full, I cannot perform this push operation directly. I print the stack is full and I exit. So initially, my top will be at -1. Initially, as we have seen, the top should always be assigned to -1 when we perform any operation on the stack. Initially, the top is at -1. That is here. Now, is top equals to size -1? No. The size of a stack here is 4. I'm taking the size of a stack is 4. Top is -1 is equals to 4. The condition is false. So we don't enter into the statement. Now I'm going to else statement. I'm reading an element. Suppose the element is 10. Now I am incrementing the top. So from -1, the top is moved to 0 location. And at stack of top, at stack of 0, whatever the element I have read, that is 10, it is inserted. That is 10. Again I'm performing push operation. Now again I'm checking, is stack full? Is no, the condition is false. So I'm going for else part. Here I'm reading the value 20. Top is incremented. So top is incremented from 0 to 1. Again at stack of 1, I'm reading inserting 20 values. So 20 is inserted here. Again I'm performing push operation, that is push 30. So what happens? Again I'm checking the if condition is false, because top is not at the last size, that is size -4. It is not at 4, so we don't enter into if statement. We are going for else part. Here I'm reading the value 30. Top is incremented to 2. Again at stack of 2, I'm reading the element, that is 30 is inserted. Now again I'm performing push of 40. It means I'm checking whether top. Now top is at 2. 2 is equals to size is 4. 2 is equals to 4. No, it is not 4. So what I'm doing, this condition is false, so I'm going for else statement. Here I'm reading a value called as 40. I'm incrementing the top. Top is going to third position. At stack of 3, I'm inserting the 40 element. Here it is. Now stack is at 3 position. This is 3, I'm sorry. Next, push 50. If I say push 50, again I'm going to push function. Here stack is at third position and the final size of stack is 4. So 4 minus 1, that is 3. 3 is equals to 3. Yes, the condition is true. So I print the statement stack is full. That is stack is overflow. We cannot insert 50 into the stack. This is how we perform the push operation onto the stack. And here we have pop operation, where if I want to delete some element from the stack, if I want to remove some element from the stack, I perform this pop operation. That when I perform pop operation on an empty stack, then it has to say that stack is empty. When the stack is empty, when top is at -1. If top is at not -1, it is pointing to some topmost element of the stack, then I go to else statement. Here I'm popping out, like here the item is nothing but the which element I'm popping out, and the stack is decremented. Here the first is check whether the stack is empty or not. When the stack is empty, when the top is pointing to -1, when I'm popping out the element, always the top will be decremented. Here we can see in detail with this example. This is a stack with already elements pushed onto it, where top is pointing to the topmost element of the stack. Now I am performing pop operation onto this side stack. When I perform pop operation, here the size of a stack is 4. The size of a stack is 4. Here top is pointing to 3. Is 3 equal to -1? No, it is not equal to -1. So we go for else statement. Here I am popping stack of top. Which element I am popping? 40. Stack of top is nothing but 3. Stack of 3 element is popped out and top is decremented. So when top is decremented, it is moving to 2. Again, if I perform pop operation, again it is checking. Now top is at 2. 2 is equal to -1? No. So it goes to else statement. Now it is popping the element at stack of top. That is stack of 2. That is 30 element got popped out. Now top is, whenever it is popped out, the top is decremented. Now top is decremented to 1. Now again, if I want to perform pop operation, 1 is equal to -1. No. So we go for else statement. Here I'm popping out stack of 1. When I'm popping up stack of 1, the top is decremented to 0. Again I'm performing pop operation. Then is 0 equal to -1? No. So it goes to else statement. Here stack of 0 element is popped out, that is 10. Next, top is decremented. When it is decremented, 0 is decremented, it is reaching to, top is reaching to -1. Top is reaching to -1. Again I'm trying to perform pop operation. Now I'm checking the top condition. Now it is -1 is equal to -1. Yes, it is true. So it prints the stack is underflow. It means you are trying to pop out an element from an empty stack. So it returns that stack is underflow. That whenever you perform a pop operation on an empty stack, it states as stack underflow. Here stack underflow states that there are no elements on the list, so stack, so you cannot pop out any element. This is the operation of pop. And if we have a stack, and if you want to see what is the data onto the stack, if you want to traverse or display the data that is present on the stack, we go for this display operation. If you want to display an empty stack, when an empty stack is displayed, when there is top is at -1. When top is at -1, you state that the stack is empty. We cannot display any data onto the from the stack. If this top is not -1, it is pointing to some topmost element, then we go for else part, and from top to 0 location we print all the elements. Let us see into the source code of it. Initially this is the stack. Here we have some 4 elements on the stack. Now I'm checking whether we can display the content onto the stack. Suppose if it is an empty stack where top is pointing to -1 and we are performing display operation, it returns the statement the stack is empty because top -1 is equal to -1. But here we have some elements on the list. Now what we do is we try to display the content. We try to display the content. See, when I perform display operation, what happens is the top is pointing to 3. Is 3 equal to -1? No, it is not equal to -1. So it goes to, it doesn't enters into if statement, it comes out and it repeats the loop. It repeats the loop. I is at top, that 3. Is 3 greater than or equal to 0? Yes. For the next time, top is decremented to 2. And it is printing stack of I, that is 3. What is stack of 3 value? 40. So 40 got displayed. Now it is 2. I is 2. 2 greater than or equal to 0. The condition is true. That I is incremented to 1. Decremented to 1. Now it is printing stack of 2. That is 30. Now again 1. 1 is greater than or equal to 0. Yes, it is true. For the next time it is decremented to 0. Now it is printing stack of 1. That is 20. 20 got displayed. Again I is 0. Is 0 greater than or equal to 0. And for the next time the top is decremented to -1. Now stack of 0. That is 10 got displayed. Again I'm checking -1 is greater than or equal to 0. The condition is false. So we exit from for loop and all the elements which are present on the stack got traversed and displayed. This is the display function to traverse the stack. Here we have two more conditions to check that whether the stack is full or empty. If I want to check whether the stack is empty, just I have one condition called when top is at -1, you state that the stack is empty. If not, you state that the stack is not empty. If you want to check whether the stack is full or not, just if top is pointing to the last block of the stack, then you say that the stack is full, else you say that the stack is not full. These are the two more conditions what we have checked. Hope you all have understood the representation of like implementation of stack using arrays, where in this we use when we have a fixed size. In the next session we'll be going to see the stack implementation using linked list. Thank you.